So to get into part two of evidence of the multiverse, today another group says they found something else in the echo of the Big Bang. These guys start with a different model of the universe called eternal inflation. In this way of thinking, the universe we see is merely a bubble in a much larger cosmos. This cosmos is filled with other bubbles, which are all universes where the laws of physics may be dramatically different from ours or relatively similar. So these bubbles probably had collided with each other using these quote unquote cosmic bruises where they touched. If so, these bruises will be visible today in the cosmic microwave background. A team consisting of Stephen Feeney at the University College of London claimed to have found evidence of this bruising in the form of circular patterns in this cosmic wave background, as depicted on the image in this slide. In fact, they found four total bruises, implying that our universe must have smashed into other bubbles at least four different times in the past. This is the first evidence of universes besides our own. In the last few weeks, several groups have confirmed Penrose's findings, while others have found absolutely no evidence of it. Expect a similar pattern for Feeney's result. The only way to settle this would be to confirm or refute the findings with better data. We may be able to get some new data thanks to Planck's spacecraft that is currently peering into the cosmic microwave background with more resolution and greater sensitivity than ever. So yeah, if you want to go to the next slide, Ryan.
Yeah. Is everyone following along so far? Sorry about that. Okay.
I think we're good. So I think when we think about ways to detect the multiverse and if we're in it or not, we consider, I'm pretty sure we all have heard of Stephen Hawking. So within his final paper titled A Smooth Exit from Internal Inflation, it may have given us a way to detect if we are part of the multiverse or not. So the inflation reference in this paper's title is the incredible expansion of space-time theorized to have occurred in the first few moments after the Big Bang, which is said to have created the universe. And many physicists believe that this inflation occurred not just in our cosmos, but happened repeatedly, spawning multiple, perhaps even go as far to say an infinite amount of universes at the same time. The problem is that we haven't had any way to detect any of these so-called other universes that happen at the same time until recently. So Stephen Hawking finished laying out the groundwork on the theory, which he hoped would prove the existence of other universes outside of our own. And he published this paper co-written with his Belgian co-written with Belgian physicist Thomas Hertog weeks before Hawking died. So the paper basically lays out the mathematics needed to build a space probe capable of detecting evidence of these parallel universes, which is also known as the multiverse. And Hawking predicted that our Big Bang was just one in an infinite number of Big Bangs that occurred simultaneously, again, which each of them created its own separate universe, aka the multiverse. Now, if the multiverse exists, or if these other universes that explode at the same time exists, we have no way to find or test it. We have no way to find them, and therefore the theory cannot be tested. That loose thread had long been a sore point for Hawking. That Hertog said this, and the story between Hawking and Hertog is that Hawking said that he did not like the multiverse, but on the other hand, he realized it was very hard to avoid when it came to this topic. Now, pretty much any reasonable model of the Big Bang which we could come up with led us to the multiverse, Hertog says. And he goes on to say, if anything is possible, if the multiverse is too gigantic, too wild, then our theory won't say anything about our own universe. So it's useless as a scientific theory. So Hawking came to him a few years later and said, all right, let's try and control the multiverse. And that's whenever they set out to write what would become Hawking's last scientific paper. And he and Hertog laid out the mechanics needed to build this space probe capable of detecting powerful gravitational waves created by multiple Big Bangs. And this gave scientists a way to actually test this famous multiverse theory.
Is everyone following along okay? All right. Before we go on, I'm just going to escape here and close my email so we don't hear any more alerts. Sorry about that, folks. Okay. Can everyone still see my screen? Can everyone still see the presentation? Okay. All right. Moving on to the next slide. We're covering finally the multiverse theories. Like how there are many universes in the multiverse, there are many theories about the concept. And the 5 theories, as we said before, is the infinite universe theory, bubble universe is theory, the daughter universe theory, mathematical and parallel universe theories. Yeah. Is everyone with me so far? Okay. Okay. For the infinite universes theory, one should note that the shape of the space-time continuum is not, well, it's most likely flat and it stretches out infinitely or goes on forever. We note that most likely because scientists are not exactly sure what the exact shape of space-time is. But in this case, it's flat and it goes on forever, like a very big piece of paper or something like that. If this space-time goes on forever, then it starts repeating at some point, because particles, the space-time particles, can only be arranged in so many ways, in a finite number of ways, which is ironic given we're talking about infinite universes. But basically, if you look far enough, according to this theory, if you look far enough out in the galaxy, you would encounter infinite versions of you. Yeah, infinite universes, infinite doppelgangers of yourself. This space-time goes beyond 13.7 billion light years, theoretically, and it's considered its own. Well, actually, sorry, I'm misspeaking. Any space-time beyond 13.7 billion light years is considered its own separate universe. So in this way, a multitude of universes exist next to each other in this giant patchwork quilt of universes, which is the image you see in the background, a giant patchwork. Each square is our universe, and our cosmos is one of them. Is everyone following me? Okay. Next up.
So getting into the bubble universe theory, it sprouts from what we talked about earlier, the eternal inflation. Now, based on research from Tufts University cosmologist Alexander Belenkin, when looking at space-time as a whole, some areas of space stop inflating like the Big Bang and aid in our own universe. Others, however, keep getting larger. So if we picture our own universe as a bubble, it is sitting in a network of bubble universes in space. What's interesting about this theory is the other universes may have very different laws of physics than our own, since they're not linked. Thus, our own universe, where inflation has ended, allowing stars and galaxies to form, is but a small bubble in a vast sea of space, some which is still inflating, that contains many other bubbles like ours. And in some of these bubble universes, the laws of physics and fundamental constants might be very different than ours, making some universes quite strange compared to ours. So yeah, we can go to the next slide.
Okay. Now we're moving on to the daughter universe theory, which in my opinion is my favorite because it's so interesting to me. Hopefully you'll find it interesting. This theory, it centers around the idea that the multiverse follows the physics of quantum mechanics, or driven by the laws of probability. By that I mean, with every choice we make, we create a universe in which we made the opposite choice, which our doppelgangers made the opposite choice. All possible outcomes of a situation that we encounter in our cosmos occur in their own separate universes. Because within the multiverse, there are infinite versions of yourself, each making different choices. This, in my opinion, is, well, actually, in the case of this theory, this is the secret of the multiverse. Billions of people making billions of choices, creating infinite Earths. For example, this little thought experiment at the bottom of the slide here. Imagine you reach a crossroads where you only have two choices. You can either go left or you can go right. In this present universe that you're in, the one that you are in, with each choice you make, it gives rise to two daughter universes, like one in which you chose to go left, or the other where you chose to go right. You understand? So basically, in our lifetime, we've made so many choices, and according to this theory, there is at least an infinite universes, one in which we each make the opposite choice. I can't say for certain like how many there are, because like we've made so many choices that, and there's so many worlds that some are so similar to each other that you could spend a lifetime trying to distinguish them. But yes, this is the Donner Universe theory. It's very interesting to me. Is everyone following so far? Okay, moving on to next slide.
So getting into the very complex theory of the mathematical universe, it's another, okay, sorry. So very complex, but to put in simple terms, it explains that the structure of mathematics may change depending on which universe you reside in. To give a quote from theory proposer Max Tegmark of the Massachusetts Institute of Technology, he says that a mathematical structure is something that you can describe in a way that's perfectly independent of human baggage. He goes on to say, I really believe that there is this universe out there that can exist independently of me, that would continue to exist even if there were no humans. So basically, scientists have debated whether mathematics is simply a useful tool for describing the universe, or whether math itself is the fundamental reality and our observations of the universe, which are just imperfect perceptions of its true mathematical nature, which would make a lot of sense because we in fact are human and we make mistakes. And if the latter is the case, then perhaps the particular mathematical structure that makes up our universe isn't the only option. And in fact, all possible mathematical structures exist as their own separate universes within this theory of the mathematical universe.
And just to entertain you folks, when it comes to math, we all make mistakes, if you know what I mean. All right, moving on. Then the last theory is none other than the parallel universe theory. In this theory, it's basically the basic idea is that with an infinite number of cosmic patches, there are infinitely many parallel universes. I'm